Here in this video, we are solving a problem based on Bernoulli's theorem. So what's the Bernoulli's theorem says? It says for an incompressible non-viscous streamlined fluid flow, the sum of potential energy, kinetic energy and pressure energy remains constant. Taking that into consideration, let me have a look at the problem given for you. This is what the problem is. The diagram shows a liquid of density 1200 kilogram per meter cube. Yeah, 100 kilogram per meter cube. So this is the liquid. This is having some density. How much is the density is given for you? 1200 kilogram per meter cube. So it is given in SI system itself. Is flowing steadily. So all the conditions like streamlined flow, they're all satisfied. Streamlined flow, non-viscous, right? Incompressible. Varying cross section. You can clearly notice that here the cross section is more, here the cross section is less. The cross section at A is given as 1 centimeter square and at B it is given as 20 millimeter square. So here at this place, area is given as 1 centimeter square, where at the point B, area 2 I am calling is given as 20 millimeter square. That's a smaller one. And they are in horizontal. You mean to say there is no height difference here. It means to say H1 is equal to H2. There is no height difference. Horizontal means that. The speed of the liquid at the point A is 10 centimeter per second. That means here there is a velocity. Liquid is going with a velocity. V1 is 10 centimeter per second. What is the difference between the pressures of the points A and B? So at the point A, if you call this pressure as P1, at the point B, if you call the pressure as P2, what he is asking you is P1 minus P2 is how much? That's what we understood the problem, right? Let's try to analyze the problem. See, it's very clearly given that at this point, velocity is 10 meter per second. But what is the velocity at the point B is not known for me. But we know we have an equation called equation of continuity. As per the equation of continuity, for a given fluid, area of cross section multiplied by velocity is constant. That comes basing on the conservation of mass, that whatever the mass of the fluid that enters per second is the mass that comes out per second. I have derived an expression. I have derived an equation for this equation of continuity. You can refer to the previous videos. See, at this A1, at this place, A1 is given for you. That is 1 centimeter square. Velocity is also given for you. That is 10 centimeter per second. A2 is also given for you. 20 millimeter square. V2 is how much? We don't know. So it's very clear. First area is in centimeter square. Second area is in millimeter square. I must make a conversion of the unit. So 1 into 10. So this 1 what I have taken is in centimeter square. This 10 is in centimeter per second itself. 20. 1 millimeter, is 1 by 10th of centimeter. That is 10 power minus 1 centimeter whole square is there into velocity V2. So 1 centimeter square multiplied by 10 centimeter per second is 20. 10 power minus 1 whole square is there. That is 10 power minus 2 multiplied by V2. So I'm just scrolling up a little. This implies, let's simplify. 1 centimeter square multiplied by 10 centimeter per second is 20 into 10 power minus 2. Centimeter power minus 2 is centimeter square itself, right? 10 centimeter square, yes. 10 power minus 2 centimeter square multiplied by V. Okay, so centimeter square and centimeter square can be cancelled. This is centimeter per second, so your velocity also will be in terms of centimeter per second. I have written units only to demonstrate that for you. So 1 into 10, I'm straight writing the values. 20, 10 power minus 2 means I can write by 100 multiplied by V2. So this is twice. So V2 will be 100 by 2, that is 50 centimeter per second. As I have taken V1 in centimeter per second, I get V2 also in terms of centimeter per second. So before even got into the Bernoulli's theorem, I have found that velocity at this point is V1, velocity at this point is V2, and I found that V2 as a 50 centimeter per second. So as we know the velocities, I can proceed further and talk about Bernoulli's theorem. So between the points A and B, what's the Bernoulli's theorem tells you? So according to that Bernoulli's theorem, the sum of potential energy, pressure energy and kinetic energy remains constant per unit mass. That is, if you remember, I have derived this in the previous video. Please look into that if you don't know this. P1 by rho plus GH1 plus V1 square by 2, that is pressure energy plus potential energy plus kinetic energy at the point A is the same at the point B. I'm not writing rho 2 because it was given like it's an incompressible fluid, so density is constant. I'm not writing, though I'm writing GH2, I'm going to equate H1 equal to H2 because he said the stream is horizontal. Velocity is different, we have already found. So as H1 equal to H2, GH1 and GH2 can be cancelled. What's remaining then? P1 by rho. Get that P2 by rho to this side minus P2 by rho. Take this V1 square by 2 that side, other side. That is V2 square by 2 minus V1 square by 2. So if you simplify this a little, P1 minus P2 by rho equal to V2 square minus V1 square by 2. As you want the pressure difference P1 minus P2, you have to take this rho to the other side. It comes to the numerator. That is rho by 2 into V2 square minus V1 square. Now if you look at the data, the rho is given to you, as I said, as 1200 in SI system kilogram per meter cube by 2. V2 square is 50 square. We have found it out. V1 square is 10 square. That is given for us. But be careful. They are given in centimeter per second. So 1 centimeter is 10 power minus 2 meter. Square is there. Therefore, whole square also comes. I'm not writing meters here because I have not written it any of the other places, the other values. So 1200 by 2 is 600. 50 square is 2500. 10 square is 100. 10 power minus 2 whole square is 10 power minus 4. That comes as 10 power plus 4 in the denominator. So it is 600. 2500 minus 100 is 2400 by 10 power 4. So these two zeros and these two zeros are 10 power 4 in the numerator, 10 power 4 in the denominator also gets cancelled. So what is remaining? 6 into 24 in SI system is an answer. So 6 fours are 24, 6 twos are 12 and 2, 144 Pascal. That's the pressure difference. So while we are solving this problem, we have taken two things into consideration. I just want to remind you. I have to calculate pressure difference between the points. To calculate the pressure difference, I need to apply Bernoulli's theorem. To apply the Bernoulli's theorem, I need to know the velocity at this point. That's why I have started with equation of continuity as A1, A2, V1 is given for you. I found V2 here. So after finding V2, I have proceeded for the Bernoulli's theorem. I have applied the Bernoulli's theorem that the sum of energies at given points is always constant. I have simplified and found the equation for P1 minus P2, and I have just substituted the values of density and velocities, but of course converted them into SI system. That's it. Thank you for watching.